Welcome everyone. I'm going to tell you about architecting with blockchain for dummies. And of course you've all come here to get an answer to this very important question: how do we solve our big data problems using blockchain? And this is a question that someone actually asked me at a conference, and I think it's a very important question because it shows how much misunderstanding there is of what blockchain is and what it's suitable for. In particular, big data and blockchain is in general not a good combination. My name is Pim Otte. I'm a software engineer or blockchain specialist at Quintor. Feel free to reflect how valid you think this second title is when you rate this talk. Currently, I'm involved in teaching the minor blockchain at Rotterdam University of Applied Sciences. And I'm also involved in a project called StudyBits, where we use blockchain technology to share credentials of students. So, what will I tell you about in the next 15 minutes? Firstly, why not to use blockchain? Blockchain is a tool with particular properties, and what I see very often is people intending to apply this tool to problems that it really has no use for. So blockchains have particular properties, and these properties describe whether or not we want to use it. This bridges nicely into the second topic, because each of these properties also have implications for the architecture of the applications that you build around it. So you have to handle them in a particular way and work with them to get the best results. So why not to use a blockchain? At some point I was at this bank, and a guy comes up to me and he says, okay, on the one hand we have this mortgage department, and on the other hand we have this risk department, and both of these departments calculate the risk of a mortgage. But they do so in different ways, which is actually hard to deal with for our business. So they get different numbers and we don't know what to do. So why don't we put a blockchain in the middle and everything will magically resolve itself? So this is actually a bad idea for not just one, but two reasons. One is the issue at hand here is a data issue. If your garbage goes in, garbage comes out. And the second is that he's trying to use a blockchain in an environment where there should be trust. And if you're doing that, then you have another problem entirely. So let's consider what a blockchain is in the abstract sense. First and foremost, it's a distributed database. If you don't have a need to store and persist your data, then you shouldn't be using a blockchain. You should be using a messaging protocol. If you are just fine running your database on a single instance, possibly with failover, you don't need a blockchain. You need a good database, and there are plenty of those. Secondly, blockchains are immutable. What this means is that whatever you persist will stay there forever. There are ways around this, but in general, this means that your blockchain grows and grows and grows and grows. This is particularly inconvenient because the distribution in blockchains tends to be full duplication. All the nodes have all information in order to compute the truth. So if you have an application where it is required for the history of your transactions, for the history of actions to be visible and verifiable, then you might have a case where you want to apply a blockchain. If this is not the case, then you really should be looking at other solutions. And finally, and this is the point where things often go most awry, is decentralization. A blockchain is not under a single party's control, or it shouldn't be. If you're using a blockchain or a distributed ledger, there should be multiple parties, each with a particular stake in this system, and each carrying part of the load. It is intended to be used in a place where these different parties exist, want to collaborate. However, there is a certain amount of distrust between these, and this distrust can provide grounds to use a blockchain and sort of resolve this and have still share the responsibility of this system without needing to trust any particular party involved. This is a very powerful tool, but it's also very it can be used in various ways, but the cases where it is really effective are really specific. So we look at public systems, cryptocurrencies, where everyone should be able to join. And the other case is often if you have a consortium of companies who want to collaborate to some level, but not too much, because they still distrust each other due to competition reasons. So if we look at the technical aspects, how do we deal with those? So firstly, distributedness. As I said, in general, the strategy is to copy all the data to each node in the network. If that raises a red flag because it's massively inefficient, that's a good sign. Then you're on track to becoming a proper blockchain expert. So what is the solution to this is actually don't use a blockchain. What I mean by this is there is a reason why you're using a blockchain. It's because there is some part of your application that needs this trust, and you cannot possibly do it in another way. That means that all parts that are not absolutely critical should not be on this shared system. To show that we practice what we preach, if we look at StudyBits, where we share credentials of students using blockchain technology, we use a platform called Sovrin, which is supported by the Hyperledger Indie project. And this allows us to store the most critical parts on a shared infrastructure. This is public key infrastructure and a revocation mechanism. So credentials that are issued can be revoked, and this revocation is stored in a central place. Then actually the bulk of the system, what is most of the data that would go through it, it's diplomas themselves. The actual data that students use to prove that they have finished a particular degree. This is actually never on a chain or a ledger. It's issued directly to the student, and the student has full control over what to do with this. This both yields a situation which is good for the users, for the students, because they are in full control of their own data. But it also helps us build this system because we don't put any unnecessary load on this shared critical infrastructure. The second part is immutability. So how do we deal with things that never can be removed? In general, you could be using some sort of update structure. You can put new things on there. And the way we actually often do this is by abusing pointers. We all know pointers as pointing to a memory location. And the thing that is used in blockchain technology is often a hash pointer, in which you take a piece of content and you use a hash function to get a hash, which is then used to identify this content and to point to it. This is also known as content-based addressing, and it's a technique where you to store a lot of information off-chain, but to save a reference within a blockchain, such that you can timestamp this piece of data, but you don't guarantee the availability of the data itself by means as heavy as a blockchain. You would use some secondary mechanism for this, which does not need this whole consensus to be reached. So let's look at how Ethereum uses pointers and how we as developers can even further abuse this. Ethereum is a blockchain platform with as key feature smart contracts. On blockchains, you have an address, and this address is governed by a public-private key pair, and signing with your private key pair authorizes transactions. And a smart contract is not that different, except that what governs whether you can do this is not a public-private key pair, but it is code. So code determines whether you spend money or not. So this raises a problem for developers, which is how to update a smart contract. Because when you deploy one, it gets an address. This address can be used to call it, but you can't actually update it in place. So the simple way to do this is to update the pointer. So you deploy a new contract, and then in the application that uses it, you update the pointer. If you use this strategy, the data that is in this smart contract gets lost. So to solve this, as all proper architectures, there's a 3-tier architecture. It works as follows. We have our DApp, our decentralized application, calling a logic contract, calling a storage contract. The storage contract is very bare bones and contains only the information that is stored, and the logic contract contains most of the, as I say, business logic that goes along with it. Suppose we want to update the logic contract. We simply deploy a new one, and we point the DApp to that contract, and the updated version to the storage contract. We then remove from our application the pointer to the initial version, and what gets left in the end is the same chain where you've updated the logic behind it. So the final aspect that we consider is decentralization. And this is a very general problem in the sense that you are deploying something to a place that is outside your control. It's a shared infrastructure, and it's not only that you are not in control, no one is in control. So the best thing to do here is prepare. The first part with this is consensus. So each blockchain, each distributed ledger has a consensus algorithm. In the case of Bitcoin and Ethereum, this algorithm is called proof of work, and whoever contributes the most computational power determines what is the truth. How you need to prepare for this is know what your consensus algorithm is, and make sure that you know how this could be threatened. So what is your threat model, and let your application take this into account. How sure are you of certain facts? And once you know this and once you design around it, you can have a solid application that actually is really, really safe. The second thing, and this is something that really comes from the Ethereum ecosystem, test everything. There's a lot of money lost in buggy smart contracts, and testing it and having it audited goes a long way. So, to sum up, the rules for using blockchain in your project. The first rule is please don't. Think about it, consider your options, make sure that you are in a situation where a blockchain actually is the right tool to use, and then go for it. Secondly, abuse pointers. And lastly, test very well. Make sure that everything is sound, and that you have that you are certain that once you deploy, this actually works. So, as it turns out, the rules for using a blockchain are sort of the same as the rules for writing something in C. Final remarks. Firstly, if you want to help Quintor develop quality software for our clients, talk to any one of us. If you want to ask questions about blockchain, I'll be here, I'll be outside, and I'll be more than happy to spar with you. So thank you for your attention.